Hello and welcome. My name is Alan. Grab you a seat, get you a drink. We're going to be working on the last piece in Ideas and Opinions by Albert Einstein. Sorry, I was messing with my tomato plants out there a few moments ago, and you can smell the plant on it. But yeah. Anyway, this is a long piece, so we're going to break it in half. Uh, by about, I guess, 8 pages. 4, 5, 6, 7. Yeah, right there. And then we'll finish the rest later. But yeah, we're at the very end here, so let's go ahead and hop into this. The name of the piece is called Relativity and the Problem of Space. Blurb reads, from the revised edition of Relativity, the Special and General Theory, a popular exposition translated by Robert W. Lawson, London, Methuen, there we go, 1954. It is characteristic of Newtonian physics that it has to ascribe independent and real existence to space and time as well as to matter. For in Newton's law of motion, the concept of acceleration appears. But in this theory, acceleration can only denote acceleration with respect to space. Newton's space must thus be thought of as at rest, or at least as unaccelerated, in order that one can consider the acceleration which appears in the law of motion as being a magnitude with any meaning. Much the much the same holds with time, which of course likewise enters into the concept of acceleration. Newton himself and his most critical contemporaries felt it to be disturbing that one has to ascribe physical reality both to space itself as well as to its state of motion. But there was at least there was at that time no other alternative if one wished to ascribe to mechanics a clear meaning. It is indeed an exact requirement um, to have at all to ascribe physical reality to space, and especially to empty space. Time and again, since remotest times, philosophers have resisted such a presumption. Descartes argued somewhat on these lines. Space is identical with extension, that extension is connected with bodies, thus there is no space without bodies, and hence no empty space. The weakness of this argument lies primarily in what follows. It is certainly true that the concept of extension owes its origin to our experiences of laying out or bringing into contact solid bodies. But from this, it cannot be concluded that the concept of extension may not be justified in cases which have not themselves given rise to the formation of this concept. Such an enlargement of concepts can be justified indirectly by its value for the comprehension of empirical results. The assertion that extension is confined to bodies is therefore of itself certainly unfounded. We shall see later, however, that the general theory of relativity confirms Descartes' conception in a roundabout way. What brought Descartes to a seemingly odd view was certainly the feeling that without compelling necessity, one ought not to ascribe reality to a thing like space, which is not capable of being directly experienced. The psychological origin of the idea of space, or of the necessity for it, is far from being so obvious as it may appear to be the basis of our customary habit of thought. The old geometers deal with conceptual objects, straight line, point, surface, but not really with space as such, as was done later in analytical geometry. The idea of space, however, is suggested by certain primitive experiences. Suppose that a box has been constructed. Objects can be arranged in a certain way inside the box so that it becomes full. The possibility of such arrangements is a property of the material object box, something that is given with the box, the space enclosed by the box. This is something which is different for the different boxes, something that is thought quite naturally as being independent of whether or not at any moment there are any objects at all in the box. When there are no objects in the box, its space appears to be empty. So far, our concept of space has been associated with the box. It turns out, however, that the storage possibilities that make up the box space are independent of the thickness of the walls of the box. Cannot the thickness be reduced to zero without the space being lost as a result? The naturalness of such a limiting process is obvious, and now there remains for our thought the space without the box a self-evident thing, yet it appears to be so unreal if we forget the origin of this concept. One can understand that it was repugnant to Descartes to consider space as independent of material objects, a thing that might exist without matter. At the same time, this does not prevent him from treating space as a fundamental concept in his analytical geometry. The drawing of attention to the vacuum in a mercury barometer has certainly disarmed the last of the Cartesians, but it is not to be denied that even at this primitive stage, something unsatisfactory clings to the concept of space, or to the space thought of as an independent real thing. The ways in which the bodies can be packed into space, the box, are the subject of three-dimensional Euclidean geometry whose axiomatic structure readily deceives us into forgetting that it refers to reliable situations. If now the concept of space is formed in the manner outlined above, the following on the experience about the filling of the box, then the space is primarily a bounded space. This limitation does not appear to be essential. However, for apparently a larger box can always be introduced to enclose the smaller one. In this way, space appears as something unbounded. I shall not consider here how the concepts of the three-dimensional and the Euclidean nature of space can be traced back to the relatively primitive experiences. Rather, I shall consider first of all, from all other points of view, the role of the concept of space in the development of physical thought. When a smaller box is situated relatively at rest inside the hollow space of a larger box, then the hollow space of the smaller box is a part of the hollow space of the larger box, and the name space, which contains both of them, belongs to each of the boxes. When the smaller box is in motion with respect to the larger box, however, the concept is less simple. One is inclined to think that the smaller box encloses always the same space, but a variable part of the space of the larger box. It then becomes necessary to apportion to each box its particular space, not thought of as bounded, but to assume that these two spaces are in motion with respect to each other. Before one has become aware of this complication, space appears to be unbounded, an unbounded medium or container in which material objects swim around. But it must now be remembered that there is an infinite number of spaces which are in motion with respect to each other. The concept of space as something existing objectively and independent of things belonging to pre-scientific thought, but not to the idea of existence of an infinite number of spaces in motion relatively to each other. This latter idea is indeed logically unavoidable, but is far from being played or having played a considerable role in a scientific thought. But what about the psychological origin of the concept of time? The concept is undoubtedly associated with the fact that of calling to mind, as well as with the differentiation between sense experiences and the recollection of these. Of itself, it is doubtful whether the differentiation between sense experience and recollection, or a mere mental image, is something psychologically directly given to us. Everyone has experienced that he has been in doubt whether he has actually experienced something with his senses or has simply dreamed about it. Probably the ability to discriminate between these alternatives first comes about as the result of an activity of the mind creating order. As experience is associated with a recollection, and it is considered as being earlier in comparison with present experiences, this is a conceptual ordering principle for recollected experiences, and the possibility of its accomplishment gives rise to the subjective concept of time. i.e., the concept of time, which refers to the arrangement of the experiences of the individual. What do we mean by rendering objective the concept of time? Let us consider an example. A person A, or I, has the experience, it is lightning. At the same time, the person A also experiences such a behavior of the person B, as brings the behavior of B into relation with his own experience. It is lightning. Thus, it comes about that A associates with B the experience, it is lightning. For the person A, the idea arises that the other persons also participate in the experience, it is lightning. It is lightning is now no longer interpreted as an exclusively personal experience, but as an experience of other persons, or the interpretation that it is lightning, which originally entered into the consciousness as an experience, is now also interpreted as an objective event. It is just the sum total of all events that we mean when we speak of the real external world. We have seen that we feel ourselves impelled to ascribe a temporal management to our experiences, somewhat as follows. If uh, something is later than A and Y later than the first, then Y is also later than A, which is a sequence of experiences. Now, what is the position in this respect to with the events which we have associated with the experiences? At first sight, it seems obvious to assume with a temporal arrangement of events exists which agrees with the temporal arrangement of the experiences. In general, the unconsciously, this was done until skeptical doubts made themselves felt. In order to arrive at an idea as an objective world, and additional constructive concepts will still is necessary. The event is localized not only in time but also in space. In the previous paragraphs, we have attempted to describe how the concepts space, time, and event can be put psychologically into relation with experiences. Considered logically, they are free creations of the human intelligence, tools of thought, which are to serve the purpose of bringing experiences into relation with each other, so that in this way they can be better surveyed. The attempt to become conscious of the empirical sources of these fundamental concepts should show that show to what extent we are actually bound to these concepts. In this way, we become aware of our freedom, of which, in case of necessity, it is always a difficult matter to make sensible use. We still have something essential to add to this sketch concerning the psychological origin of the concepts space-time event. We will call them more briefly space-like, in contrast to concepts from the psychological sphere. We have linked up the concept of space with experiences using boxes and the arrangement of material concepts in them. Thus, the formation of concepts already presupposes the concept of material objects, e.g., boxes. In the same way, persons who had to be introduced for the formation of an objective concept of time also play the role of the material objects in this connection. It appears to me, therefore, that the formation of the concept of material object must precede our concepts of time and space. All these space-like concepts already belong to the pre-scientific thought, along with the concepts like pain, go, purpose, etc., from the field of psychology. Now, it is characteristic of thought in physics, as thought of a natural science generally, that it endeavors its principle to make do with the space-like concepts alone, and strives to express with their aid all relations having the form of laws. The physical seeks to surface or to reduce colors and tones to vibrations. The physiologists thought and pain to nerve processes in such a way that the physical element is illuminated from the causal nexus of experience or existence, and thus nowhere occurs as an independent link in the causal associations. It is no doubt this attitude which considers the comprehension of all relations by the exclusive use of only space-like concepts as being possible in principle that it is at the present time understood by the term materialism, since matter has lost its role as a fundamental concept. Why is it necessary to drag down from the Olympian fields of Plato the fundamental ideas of thought in natural science, and to attempt to reveal their earthly lineage? Answer: in order to free these ideas from the taboo attached to them, and thus to achieve greater freedom in the form of greater freedom in the formation of the ideas or concepts. It is to the immortal credit of D. Hume and E. Mach that they, above all others, introduced this critical conception. Science has taken over from pre-scientific thought the concepts, space, time, and material objects, with the important special case solid body, and it's modified them and rendered them more precise. Its first significant accomplishment was the development of Euclidean geometry, whose axiomatic formulation must not be allowed to blind us to its empirical origin, the possibilities of laying out or juxtapositioning solid bodies. In particular, the three-dimensional nature of space as well as its Euclidean character are of empirical origin. It can be wholly filled by like constituted cubes. The subtlety of the concept of space was enhanced by the discovery that there exists no completely rigid bodies. All bodies are elastically deformable and alter in volume with change in temperature. The structures whose possible configurations are to be described by Euclidean geometry cannot therefore be characterized without reference to the content of physics. But since physics, after all, must make use of geometry in the establishment of its concepts, the empirical content of geometry can be stated and tested only by the framework of the whole of physics. In this connection with atomistics must also be borne in mind, and in conception of finite divisibility for spaces of subatomic dissection or extension cannot be measured up. Atomistics also compels us to give up in principle the idea of sharply and statically defined bounding surfaces of solid bodies. Strictly speaking, there are no precise laws, even in the macro religion of the possible reconfigurations of solid bodies touching each other. In spite of this, no one thought of giving up on the concept of space, for it appeared indispensable in the eminently satisfactory whole system of natural science. Mach, in the 19th century, was the only one who thought seriously of an elimination of the concept of space, in that he thought to replace it by the notion of the totality of the instantaneous distances between all material points. He made this attempt in order to arrive at a satisfactory understanding of inertia. So yeah, we'll go ahead and end this part of the piece there. So Einstein, excuse me, I'm trying to wipe my face down. I am sweating. My glasses keep slipping. You could probably hear my arms going squeak against my chair. I was not passing gas, I swear. But yeah, Einstein talking about how we can view space. how we can measure space, and how we can put it to further use in physics. But yeah, we'll go ahead and end that part there. Hopefully, with the next episode, we will go ahead and end the book because we only have about eight and a half pages to go. But as always, thank you for watching. Uh, educate thyself. Think, read, study, learn. Someone tries to tell you something you have trouble believing, ask them to cite their sources. I'll see you all in the next video. Until then, later.